constants are also assumed to be a constant, the speed of light and the gravitational constant. But again, there's very little evidence they really are. Measurements in the 20th century showed remarkable variations. For example, the speed of light dropped by about 20 kilometers per second all over the world between 1928 and 1945. When you look at measurements from different labs, they were shown with tiny error bars, suggesting these were very accurate measurements to many places of decimals. And then after 1945, it went up again to somewhere near the previous value. And at first there were bigger error bars, and then it settled down until they became much smaller. Now, did the speed of light really change, which is what the data tell us, or not? I didn't know what to think, so I went to see the head of metrology at the National Physical Laboratory, Dr. Brian Petley, who was kind enough to see me and discuss this with me. And he's the British expert on the constants. He's our representative, or was, on the International Committee of Metrology, which sets the international values of the constants. So I asked him about the speed of light dropping by 20 kilometers per second. And I said, could the speed of light really have dropped by 20 kilometers per second during that period? He said, no, of course not. And I said, well, why not? He said, well, it can't change, it's a constant. So I said, but the measurements show it did change. So how do you explain that? I said, do you think people were just fudging the values because someone got a low value and then they all tried to agree with it and fudged the values of what their measurements were to agree with what everyone else was getting? He said, well, we don't like to use the word fudge. And I said, well, what word do you prefer? And he said, we prefer to call it intellectual phase locking. So I said, well, if it's so unreliable and there's a whole community of metrologists all over the world were getting this value that was so different, how can we trust the measurements today? He said, oh, we've solved the problem with the speed of light. I said, oh, how? He said, well, in 1972, the International Committee defined it. I said, you mean it's fixed by definition? And I said, but what if it really changes? He said, it can't. And I said, well, why not? He said, because we've defined the meter in terms of the speed of light. So if the speed of light changes, the meter will change its length as well, and you won't know the difference. Well, that's the state of play at the moment. The gravitational constant, however, is fluctuating wildly, and even in the last few years has varied by 1.3%. I mean, these are huge differences when these are considered to be things accurate to many places of decimals. I think the constants may well fluctuate within certain limits, and I think the day may come when you open scientific periodicals like Nature, and there'll be, like stock market reports in newspapers, things like, you know, this week the gravitational constant was marginally up, the fine structure constant held steady, the charge on the electron was down, and so on. And if that's true, the quality of time would change with these constants. Different things could happen at different times. So this is an open question. And the idea that the laws of nature evolve is, I think, very much an open question, and it fits the facts much better than the idea of fixed laws, which is simply an assumption carried over from an older cosmology.